Hello everyone, my name is Tushar Duar, Assistant Professor in Civil Engineering Department, Dr. Subhash Technical Campus, Junagadh. Welcome to my YouTube channel. Today I am going to take a lecture of design of reinforced concrete structure, which is offered in 7th semester. Chapter retaining wall and unit 2. What is a retaining wall? Retaining wall is a structure used for maintaining the ground surface at different elevation on the either side of it. Next, the main component of retaining wall: first, stem vertical portion; second, toe slab green color horizontal portion; third, heel slab violet horizontal; backfill, shear key. First, what is backfill? The material retained or supported by retaining wall is called backfill. Next, whip wall. To release the pore water pressure developed in the backfill material during rainy season, whip wall are provided in the retaining wall. Next, application of retaining wall. Construction of basement below ground level in building. Second, wing or wall and abutment in a bridge work are designed as retaining wall. Third point, to retain slope in hilly terrain road. Fourth, as side wall of bridge approach road. Fifth, to provide lateral support to embankment. Next, types of retaining wall. Retaining wall are classified according to the shape and mode of resisting the pressure. The different types of retaining wall: first, gravity retaining wall; second, cantilever retaining wall; third, counterfort retaining wall; fourth, buttress retaining wall; fifth, bridge abutment; and last, box culvert. Generally, two types of retaining wall used in this chapter: cantilever retaining wall and counterfort retaining wall. Next, classification of retaining wall. First, gravity retaining wall; second, shape cantilever retaining wall. Three types: T shape, L shape, and T shape with shear. Counterfort retaining wall, buttress retaining wall. Next, this is image of retaining wall: gravity retaining wall, cantilever, buttress, precast concrete retaining wall, precast concrete crib retaining wall, ship pipe wall. Next, first gravity retaining wall. The gravity wall provides stability by virtue of its own weight and therefore rather massive in size. Second point, it is usually built up in stone masonry and occasionally in plain concrete. The gravity wall provides stability by virtue of its own weight and therefore rather massive. Okay. This is image massive masonry unit stone and procedure concrete. Stress develop is very low. Gravity retaining wall stress develop is very low. Wall are so proportional that no tension is developed anywhere and resultant of force remaining within middle third of the base. Next, cantilever retaining wall. Cantilever retaining wall The cantilever wall is most common types of retaining wall. Retaining structure and is generally economical for height up to 6 meter. Cantilever retaining wall generally economical for height up to 3 meter. Gravity retaining wall generally economical for height up to 3 meter. The structure consists of vertical stem and a base slab made up two distance region, heel slab and toe slab. First, stem act a vertical cantilever under the lateral earth pressure. Stem vertical portion से cantilever under lateral earth pressure जो soil pressure वहाँ है. Second, heel slab act a horizontal cantilever under action weight of the retained earth minus soil pressure acting upward from below. Toe slab act a cantilever under action resulting soil pressure acting upward. Next, cantilever retaining wall, it resists horizontal earth pressure as well as other vertical pressure by way of bending of various components acting as cantilever, may be shaped L-shaped or T-shaped. Next, counterport retaining wall. Counterport, what is counterport retaining wall? Stem and heel slab are strengthened by providing counterport at some suitable interval. The stability of the wall is maintained essentially by the weight of earth on the heel slab plus the self weight of the structure. For large height in cantilever retaining wall, the bending moment developed in the stem, heel slab and toe slab become very large, required large thickness The bending moment can be considerable reduced by introducing transverse support is called counterfold. This is a counterfold retaining wall. Counterfold wall are placed at regular interval about 1/3 to 1/2 of the wall height, interconnecting the stem with heel slab. This wall economical height above approximate 7 meter, gravity retaining wall economical height up to 3 meter, cantilever retaining wall up to 6 meter, and counterfold retaining wall. This wall is economical for height above approximately 7 meter. The counterfold is subdivide the vertical slab stem into rectangular panel and support them on two sides and themselves behave essentially a vertical cantilever beam of T section and varying depth. Next point, force acting on retaining wall. First of all, retaining wall, vertical portion is stem, ground level, top width of stem, right hand side horizontal portion heel, left hand side horizontal portion toe slab, W3, backfill of soil, bottom width of retaining wall, B, top width of retaining wall, A, total height retaining wall, capital H, active earth pressure diagram, right hand side, left hand side passive earth pressure diagram, bottom uplift pressure diagram, active pressure diagram of soil, bottom માંથી soil uplift pressure diagram, base active earth pressure diagram, base KA active pressure K gamma weight of soil, unit weight of soil, small h total height of retaining wall, maximum pressure at retaining wall at height of h/3 distance, maximum pressure of retaining wall of soil. Passive earth pressure diagram, Kp coefficient of passive earth pressure, gamma unit weight of soil, h1 height of pressure diagram. Force acting on retaining wall, W1 stem, W2 heel slab, and W3 backfill of soil. Next. The various force acting on retaining wall. First, lateral earth pressure. Second, self weight of retaining wall. Third, weight of soil above the base slab. Fourth, surcharge force due to load on the earth's surface. Fifth, soil reaction below the base slab. Last, frictional force at the bottom of the slab. Next, first point, lateral earth pressure. The lateral force due to earth pressure is the major force acting on the retaining wall. Active earth pressure by Rankine theory for cohesion-less soil. We shall consider the following case of cohesion-less backfill. First, dry or moisture backfill with no surcharge. Second, submerged backfill. Third, backfill with uniform surcharge. Fourth, backfill with sloping surcharge. Fifth, include backfill with surcharge. Inclined backfill, inclined back and surcharge. Okay. So first, earth pressure P. Earth pressure is pressure expected by the retaining material on retaining wall. These pressures tend to deflect wall outward. Types of earth pressure: active earth pressure or earth pressure PA, and passive earth pressure PP, denoted by PP. Active earth pressure tend to deflect to vertical wall away from backfill. Variation of earth pressure. Factor affecting earth pressure. Earth pressure depend on types of backfill and height of wall and soil condition. Next, first point, dry or moisture backfill with no surcharge. Most important point, retaining wall and active earth pressure diagram. Bottom active earth pressure diagram, bottom width, Ka coefficient of earth active pressure, gamma density of soil, height, total height of earth pressure diagram. So pressure at the base of the wall, तो प्रेशर डायग्राम है, उसका बेस प्रेशर कितना है, तो के ए गामा इंटू हाइट. टोटल प्रेशर एक्टिंग ऑन होल तो इज इक्वल टू एरिया ऑफ प्रेशर ट्रायंगल. प्रेशर डायग्राम का शेप ट्रायंगल है तो उसका एरिया क्या होगा, 1/2 गामा के ए गामा हाइट इंटू हाइट. तो टोटल प्रेशर क्या हो जाएगा, पी ए इज इक्वल टू 1/2 इंटू के ए इंटू गामा इंटू हाइट स्क्वायर एच स्क्वायर. This pressure act at height h/3 above the base of the hole. If the soil is dry, unit weight is dry weight of soil. If soil is moist, unit weight the moist weight of soil. Next, where Ka is equal to coefficient of active earth pressure is equal to Ka is equal to 1 minus sin theta divided by 1 plus sin theta is equal to tan square. So Kp is equal to 1 1 by K coefficient of passive earth pressure. Theta is equal to angle of internal friction Kp is equal to coefficient of passive earth pressure. Kp is equal to 1 by Ka. Theta is equal to angle of internal friction or angle of repose. Gamma is equal to unit weight of density of backfill. Theta is equal to generally 30. K is equal to 1 by 3. એંગલ 30 હોય ત્યારે 1/3 આવે અને એંગલ 30 હોય ત્યારે Kp પેસિવ અર્થ પ્રેશર કોએફિશિયન્ટ ઓફ પેસિવ અર્થ પ્રેશર 3 K is equal to 9 times Kp. Next, submerge. Second point, submerge backfill. In this case, the sand behind the retaining hole is saturated with water. The lateral earth pressure is made up of two components. First, lateral pressure due to submerged weight gamma of soil. यहाँ पे जो फर्स्ट डायग्राम दे रखा है प्रेशर का, एक्टिव अर्थ प्रेशर का, वो लेटरल प्रेशर ड्यू टू सबमर्ज वेट. तो प्रेशर क्या, बेस का प्रेशर क्या हो जाएगा, के ए गामा डैश इंटू हाइट. सेकंड प्रेशर जो लग रहा है लेटरल प्रेशर ड्यू टू वाटर, तो उसका क्या हो जाएगा, गामा डब्ल्यू वेट ऑफ वाटर, यूनिट वेट ऑफ वाटर इनटू हाइट. तो टोटल प्रेशर क्या हो जाएगा, लेटरल प्रेशर ड्यू टू सबमर्ज वेट प्लस लेटरल प्रेशर ड्यू टू वाटर. तो टोटल प्रेशर एट बेस PA इज इक्वल टू कोएफिशिएंट ऑफ एक्टिव अर्थ प्रेशर इनटू डेंसिटी ऑफ सॉइल इनटू हाइट प्लस density of water, unit weight of water into height, water on side. Second, if the free water stand to both sides of wall, the water pressure need no consider and the net lateral pressure PA is equal to coefficient of active earth pressure into unit weight of soil into height. Both side water, left hand side or right hand side, left hand side water pressure minus right hand side water pressure, so only soil pressure Ka coefficient of active earth pressure into unit weight of soil into height. Submerge backfill. If the backfill is partially submerged, backfill is most to depth height below the ground level, then it is submerged. The lateral pressure intensity at the base of the wall given by first soil pressure is equal to coefficient of active earth pressure into unit weight of soil into height, saturated soil up to saturated soil height H1, moisture soil height H1, saturated soil height H2, total height small capital H, plus coefficient active earth pressure into density saturated soil into height H2 saturated soil, plus water unit weight into height H2. Stability of cantilever retaining wall, most important topic. Stability of cantilever retaining wall. एग्जाम्पल में आता है चेक फॉर स्टेबिलिटी, फोर्स मार्क्स के लिए a cantilever retaining wall is subjected to following force. So in figure, first W1 जो स्टेम में दे रखा है, स्टेम की जो वर्टिकल फिगर उसमें दे रखा है, W2 हिल स्लैब में, डॉट W3 ई बैकफिल ऑफ सॉइल. तो वेट ऑफ स्टीम W1, सेकंड वेट ऑफ बेस स्लैब W2, थर्ड वेट ऑफ सॉइल सपोर्टेड ऑन हिल स्लैब W3, एंड फोर्थ horizontal acting earth pressure acting at height h/3 above the base level. Okay. Design step of retaining wall. Step number 1, coefficient of active earth pressure. Second step number 2, primary dimension अथवा बेसिक डायमेंशन में width of beam, thickness of stem. थर्ड स्टेप स्टेबिलिटी कैलकुलेशन में हॉरिजॉन्टल लोड कैलकुलेशन, वर्टिकल लोड कैलकुलेशन, मैक्सिमम प्रेशर एट टो, मैक्सिमम प्रेशर एट heel, factor of safety against sliding. Fourth step, design of steam માં distribution steel, culturement of bar, check for shear. Fifth step, design of hill slab, and last design of toe slab. Generally, coefficient of earth pressure, basic dimension, check for stability, and one design of steam, design of slab, or design of toe slab, or design of hill slab. Okay, thank you.